Hello and welcome to the 𝐒𝐚𝐦𝐚 podcast. I'm Aniket and today we're exploring the invisible systems that keep modern cars running, not just engines and tires, but the digital networks inside your vehicle. From airbags deploying in milliseconds to your car streaming music to self-parking systems, all of it relies on hidden protocols that most of us never hear about. To help us understand this, I'm joined by Rajiv, an automotive embedded systems engineer who works hands-on with these technologies every single day. From 𝐒𝐚𝐦𝐚 bus to automotive Ethernet, Rajiv's job is to make sure every electronic control unit in a car talks to each other reliably and safely. Rajiv, welcome to the podcast.
Thanks, Aniket. Excited to be here. Cars today aren't just machines anymore. They're computers on wheels, and what makes them work smoothly isn't just the hardware, but the protocols that let hundreds of electronic parts talk to each other without fail.
Okay, let's start with the basics. Rajiv, why don't modern cars just have wires connecting everything? Why do we need this thing called 𝐒𝐴𝐴n bus?
Great question. Imagine if every button in your car had its own dedicated wire going to every component. You'd have hundreds of wires running all over the place. Heavy, expensive, and prone to failure. That's where 𝐒𝐴𝐴n bus comes in. It's like a group chat for your car's electronic control units, or ECUs. Instead of one-to-one connections, all the ECUs, the engine, brakes, airbags, sensors, connect to the 𝐒𝐴𝐴n bus and messages get broadcast across it. Any ECU that needs that info listens in. For example, when you press the brake pedal, the brake ECU sends a message onto the 𝐒𝐴𝐴n bus. The engine ECU hears it and reduces power. The ABS hears it and checks wheel speed. Even the brake lights ECU hears it and switches the lights on. All from a single message. You know what's even more interesting? They've actually created different types of networks for different purposes. There's this thing called LIN, Local Interconnect Network, that handles all the simple stuff like power windows and mirrors. It's like having local roads versus highways in your car's communication system.
So basically, 𝐒𝐴𝐴n is like the WhatsApp group where all the car parts hang out.
Exactly. Instead of shouting at each other through hundreds of wires, they use one shared language on one shared bus.
Alright, so that covers the big stuff like brakes and engines. But what about smaller things like windows, mirrors, or seat adjustments?
That's where LIN comes in, the Local Interconnect Network. Think of it as 𝐒𝐴𝐴n's little sibling. It's simpler, cheaper, and designed for low-cost electronics. For example, in a car door, you've got a window motor, a mirror adjuster, maybe a door lock. None of these need high-speed communication. LIN handles them cheaply and efficiently.
So 𝐒𝐴𝐴n is like the express highway and LIN is like the local service road?
Perfect analogy. You wouldn't put a bicycle on the expressway, and you wouldn't waste a highway just to carry groceries across the street. 𝐒𝐴𝐴n handles the critical fast stuff. LIN takes care of the little local details.
Now, I've heard of something called FlexRay. Where does that fit in?
FlexRay is the protocol we use for safety-critical high-speed systems. Things like airbags, electronic power steering, or advanced driver assistance features. The beauty of FlexRay is that it's deterministic, meaning the timing of messages is guaranteed. In safety systems, that's crucial. If an airbag ECU needs to send a signal, FlexRay ensures it gets there at exactly the right time. No delays.
So this is like the Formula 1 version of 𝐾AN. Faster, stricter, and no room for error.
Exactly. FlexRay is over-engineered for reliability. It's not used everywhere because it's more expensive, but in life or death systems, it's worth it.
Cars these days feel more like laptops on wheels. Cameras, sensors, even streaming Netflix in the backseat. How do protocols keep up with all that data?
That's where automotive Ethernet comes in. Unlike 𝐒𝐴𝐴n or LIN, which handle smaller messages, Ethernet can handle the gigabytes of data modern cars generate. Think about autonomous driving. A single high-definition camera can generate hundreds of megabytes per second. Add LiDAR, radar, and multiple cameras. You need a network that can handle it. Ethernet is perfect for that, and it's already in most modern vehicles.
So cars are basically becoming rolling data centers.
Absolutely. And just like in data centers, Ethernet is the backbone connecting sensors, processors, and infotainment systems together at high speed.
Now this one blows my mind. Cars talking to traffic lights or even to each other. Is that real or just science fiction?
Imagine you're approaching an intersection and another car is about to run a red light. Your car could warn you or even brake automatically because it heard the other car's signal. That's V2X in action.
So one day cars could literally prevent accidents by warning each other?
Exactly. It won't eliminate all accidents, but it will reduce them dramatically, especially in busy urban areas.
And what about telematics, like when my car sends data to the manufacturer, or when the navigation just knows exactly where I am?
That's telematics protocols plus GPS. Telematics is what enables remote diagnostics, over-the-air software updates, emergency calling, and fleet management. For example, if your car detects a fault, it can send a code back to the manufacturer. Or if you're in an accident, telematics can automatically call emergency services with your GPS location.
So that's why cars now get software updates like smartphones.
Exactly. Tesla popularized it, but now almost every manufacturer is adopting over-the-air updates. It's all powered by telematics protocols in the background.
So to recap, �CANLIN, FlexRay, Ethernet, V2X telematics. They sound technical, but together they're the nervous system of modern vehicles.
Exactly. Without them, cars would be heavy, clumsy, and unsafe. With them, they're smart, efficient, and increasingly autonomous.
And that's the big takeaway. Cars aren't just machines anymore. They're computers on wheels, powered by invisible protocols working tirelessly in the background. That's all for today's episode of the Samayama podcast. I'm Aniket. Stay safe on the road, stay curious, and remember, the future of transportation isn't just about engines, it's about connections.